I am now 20 nanometers tall. So, an individual transistor from a brand new 2026 M5 MacBook Pro is about the size of a garage for me. Now, I'll note that this most likely isn't 100% accurate because Apple's not going to share their exact chip architecture with me, but still, the smallest parts of it are still smaller than me, and at this scale, you can see individual atoms, which are the size of marbles. Now, obviously, or maybe not obviously, but 3 nanometer transistors this size aren't just built like other objects the way you might be expecting. There's a pretty refined manufacturing process called photolithography. Basically, it's like developing a photo with light projected through a microscope, but onto atoms instead of film. And that is how you end up with billions of these inside a computer that you can sit on your lap. Now, to be honest, I don't really know how much longer Moore's law can apply to semiconductors as they get down to the literal atomic level, but I sure do want to appreciate it while it's happening. Speaking of appreciating it, hey, this is Epic Spaceman. One of my favorite creators, and of course a massive help with this video. He's been down to this scale before in another video, and it's a pretty crazy view, right?
Hi, Marques. Yeah, it really is. Even when you can stand on them, I still struggle to get my head around how many transistors there are here, considering this is just a tiny cutout section. The full chip is 32,000 times bigger than this.
So yeah, the best way for my brain to really appreciate all of this has been to visualize this scale. From the tiniest 3 nanometer transistors we have in computers today, at the scale of DNA and individual atoms, all the way to the micrometer scale with the computers of the 2000s and 90s and 80s, humanity has been so motivated for so many years to get this stuff down to such a ridiculously small scale that it makes a grain of rice look like a massive object. And yet it keeps going and going, all the way back to the earliest transistors the size of a deck of cards. You know, something else I've realized though, even though we've seen now all of this scale and how tiny things can get, sometimes it can still be hard to keep all the nanometers and picometers sorted and really comprehend it all. And sometimes it's actually easier to make things bigger rather than smaller. So let's try this. The world's first electronic computer is often credited as the ENIAC. They finished it in 1946, and they had light bulb-sized vacuum tubes called triodes. And of course, that computer was the size of a whole room. But if we still made computers like this, with transistors that big, how big do you think the iPhone would need to be to fit the 19 billion transistors that it has today? Think about it. Maybe the size of a city block? Or what about the size of the entirety of Central Park? Keep in mind, you need to fit all these billions of transistors. Wouldn't it be crazy if we carry around the equivalent technology of a phone the size of the city of Manhattan? Well, the reality is these are all still too small. Your phone, with the technology from 80 years ago, would need to be the size of the state of New Jersey to fit them all. This progression of technology has given us a computer the size of a US state 270 miles long and shrunk it down to fit in our pockets. Thanks for watching. See you in the next one. Peace.